This RapidMiner tutorial will focus on text classification in RapidMiner. I'm going to use the read Excel operator to import data from a spreadsheet, which contains about 500 job postings, together with the category in which they have been posted. From the job postings, I calculate the word frequencies and use an algorithm called k-nearest-neighbour to automatically categorize the documents into categories. So we basically train the algorithm to categorize a document from previous examples, and then it should be able to automatically categorize other ones into the correct categories later. From our cross-validation, we get a nice matrix like this, which shows us the performance. For example, here are the results for the software category. It gets it right 23 times and gets it wrong a couple of times, but 92% class recall is pretty good. Overall, it's able to classify documents with 82% accuracy, which isn't bad, and the more documents it has, the better it's going to be. I'm going to step through the process. I'll be using operators from the text processing and web mining extensions. If you don't have these extensions installed, go to the Marketplace in the Extensions menu and install from there. I'm using the nominal to text operator to convert the job posting information to text, and applying it to a single attribute, which is the job description text, so job text. I'm using the filter examples operator to select only job postings from certain categories. I'm just selecting a few categories, as you can see here. The category has to be equal to food, beverage, hospitality, or sales, and so on. I'm doing this as some of the categories had just too few examples to train the model on. Then I use the process documents from data operator. Inside, I begin with the extract content operator, which is from the web mining extension. It strips out all HTML code and tags from the text and leaves everything else. Transform cases converts all the text to lowercase, so we can ignore capitalization. I replaced a couple of tokens such as e-mail into email and I'm into I am. Then tokenize turns them into individual words, filtered out the most common words like and in. Stemmed the words, which means getting rid of the pre and suffixes. So experience becomes experience and experiences becomes experience, so it counts them the same. Filter out the single words and calculate the TF-IDF score, and prune out words that only appear in one document. Now, to get the category from the read Excel operator through the process documents from data operator, you have to select add meta information. That'll let the category column pass through. Then I use the select attributes operator to filter out some of that unnecessary amount of data tags that this parameter adds, like the language or document title. They are all just blank in my case, so I can get rid of them by selecting only columns with no missing values. Then I set the role. The role that you want for the category is going to be the label, which is equivalent to your Y variable in a regression, so the dependent variable. Then the name of the label is the category column, so I'm going to learn which category goes where, and then try to predict the category later. Just pretend that's your Y variable in here in terms of regression. Then, in the cross-validation, it basically takes the whole data set, grabs a random portion of it. I'm using 5 cross-validations here, so it'll do 5 iterations. In each, 80% of the data is used for training and the remaining 20% for testing. In that way, it can get a better understanding of its actual error rate, and all examples can be used for training and testing. Cross-validation is a sub-process operator, and it has 2 parts. In the training section, you add your learning algorithm here, and then on the testing side, you apply a model, calculate the performance. You can just leave those defaults there. Here I'm using the nearest neighbour algorithm, which is the KNN operator, and you have to pick your number of neighbours. I pick 3 here, and then I use the cosine similarity to find the nearest neighbours, which is generally appropriate for text documents. I'm just going to run that. That was actually pretty quick, only 5 seconds. From the cross-validation operator, you get back your example set in its regular form. Also, you can find some details about the model that was created. So I use these 5 categories here. Then it gives you the performance accuracy of the model and the uncertainty in terms of classifying documents. When it predicts food or beverage category, it gets it right more than 50 times, but it gets it wrong a few times. When it predicts healthcare, it gets it right about 20 times and then gets it wrong a few other times. It performed worst on the skilled trades one and performed the best on the software, probably because there's more software words that are easier to discriminate on than compared to skilled trades. And that's basically how word categorization works. The reason I picked 3 nearest words is because I did it a few times and found that 3 provided the highest accuracy. You can also use the optimize parameters operator, which I have pre-configured here. That'll put an outer loop outside of cross-validation, and it will pick the right number of nearest neighbours for you. It'll run it several times, and whichever number of nearest neighbours has the highest accuracy, it'll pick that one. As you can see here, for a K of 3, the accuracy is highest. I'm also going to look at using naive Bayes, which is another popular word classification algorithm. A lot of spam filters use it. This one didn't get as good accuracy as KNN, but it's useful to show how important certain words are to a particular class. That was pretty fast too, only 5 seconds. Performance-wise, at 74% isn't too bad, but KNN is better. If you look at the distribution table, you can see, for example, the food-beverage category, that these were the most important words. So Indian, cook, Korean, breakfast, chef. HR is probably hours, dollar per hour, or working hours. Server, kitchen, shift. So it kind of makes sense. These are weightings of each word for the model. For healthcare, so CDA, a certified dental assistant, receptionist, care patient, all sorts of things. DR is probably doctor. Sales, we've got telemarketing, market, promotion. These are the stemmed words. So naive Bayes can be a good way to look at which words are important to classifying a document. KNN won't tell you that, but it can be a bit more accurate on the other hand. So it's good to play with a few different types of learners. You can also use support vector machines. Those can generally only be 2 classes at a time. Other ones can do multiple ones. So that's document categorization. I talked about passing a category through the process documents upward, setting the right role to the right column, cross-validation, and how it's good for finding proper error rate and then picking different training algorithms between KNN and naive Bayes, and then looking at the accuracy of a learner, as well as figuring out which words are important in terms of classifying. This concludes this tutorial on text classification in RapidMiner.